Okay, so we're looking at the natural extension to what we've just done on sums and differences, and they're called double angle formulae. Plural of formula is formulae. So just remember what we did in the video, sine A plus B cos A plus B tan A plus B. So they're the formulas, and what we're doing is what happens when the second angle is the same as the first angle. So come across when you're ready. Okay, so when A and B are the same things, you get 2A. If you have a look at the formula, I've got sine A cos A, sine A cos A, sine A cos A, so I've got two of the same things. So that's the first formula. So when you have sine 2A, you have 2 sine A cos A. And again, you're going to have access to a cheat sheet. Okay, it's mindful minute at the moment. Okay, so cos A plus A is the same as cos 2A. And if you look at the formula, I've got cos A, sine A, sine A. So I've got cos squared minus sine squared. But, we know from earlier that sine squared plus cos squared equals 1, so you get 2 extra formulas. So in the first formula, like for instance, in the first formula, if I make sine A the subject, then cos A has to go across, so it's 1 minus sine squared. And so you end up with minus, and a minus is minus 2 sine squared A. Or if you take sine squared across the other side, you end up with 1 minus sine squared. So you end up with another formula. So you get, if I replace sine squared with 1 minus cos squared, and then I've got minus, and a minus is a plus, so I end up with 2 cos squared A minus 1. So there's 3 formulas for cos 2A, which you have to know. And with the last one, tan A plus A is tan 2A, so it ends up being 2 tan A over 1 minus tan squared A. So how do you use it? Let's have a look. Okay, so looking at an example, finding sine 2 theta cos 2 theta if you know one of the ratios. And you get this extra information which tells you what quadrant you're in. So if you're between 0 and pi on 2, you're in the first quadrant, so all the ratios are positive. Now, so you're told that sine is 12 over 13, so there's the angle, so it's opposite over hypotenuse is 12 over 13. So you have to use Pythagoras to find the missing side, or you know that the triad 5, 12, 13 should be familiar with you. So in the end, cos theta is 5 over 13, and not that you need to know it, but if you did need to know it, then you know tan theta is opposite over adjacent. So you don't need to know it for this question, but it's 12 over 5, but you don't need it. So sine 2 theta equals 2 sine theta cos theta, and you've got sine theta, and you've got cos theta, so you just plug it into the formulas and get a fraction answer. And with the last one, with cos 2 theta, there's 3 ways of doing it. I'm going to use 2 cos squared minus 1, so you end up with 2 times 5 13 squared minus 1, blah, blah, blah. You end up with a negative fraction. Don't be too worried. This means that it's going to be in the second or third quadrant for cos being 2 theta. Okay, so looking at next example, finding exact value of sine 15 cos 15. And you have to remember some of these little formulas. So sine 2A equals 2 sine A cos A. So basically what we've got is that's your sine 15 cos 15 part of the question. And so we just have to get rid of the 2. So sine 15 cos 15 equals a half of sine 2A. So 2A is 2 15s. So it's a half of sine 30. Sine 30 is a half. So you end up with a quarter. Copy that down, ready when you come across. And the last one, these are the good ones, proving things. Now, they don't have an equal sign, they have this triple equals. It just means equivalent to, so it's an identity. Okay, so these aren't equations, these are identities, not equations. So these end with these triple equal signs. Okay, so when you have proving questions, you can't cross over the equal signs. You have to work left-hand side or right-hand side and make them equal to each other. So the right-hand side looks beautiful, tan A, so we have to manipulate the left. So we've got sine 2A equals the top line, the bottom, 1 plus cos 2A. Now, we've got to get rid of, okay, you've got to recognise that tan, we're looking for a sine over cos, which means that we've got to get rid of some of the things we don't want. So like for instance, we don't want cos, so we have to work on how do we eliminate cos. And if you look at the cos 2A formula that just has coses in it, not sines, you end up with 1 plus 2 cos squared A minus 1, and the 1 and the minus 1 cancels out, so you're just left with 2 sine A cos A from the top and 2 cos A from the bottom. The 2's cancel out, and one of these coses cancels out with one of those coses, so you're left with sine over cos. Sine over cos is tan, and so you've proved it equals the right hand side, which is a the proof. Okay, so that's the end of that video, and there'll be exercises in the textbook on the blue book, 24.2 I think.